there's so much concrescence of time and compression of historical development going on in the world right now that you can hardly pick up a journal in your favorite field without seeing that all paradigms are being challenged. And this is happening regardless of, the area you're working in. It may be the design of solid-state circuitry, it may be quantum mechanics or cosmology or information theory. There are simultaneously now going on so many breakthroughs in the investigation of nature and mathematics that one of the themes of these discussions will be how unpredictable the consequences are of all this knowledge flowing together. No one is planning how these various technologies, insights, and tools are going to fit together. And in a way, it creates opportunity, because there is so much chaos, because very small forces can exert major changes. I'm sure you all know the cliche about the butterfly whose wing beat starts the hurricane. I got a fax the day before I came down here saying that Interpol had put out an all-points bulletin for that very butterfly and was attempting to corner it and to halt the hurricane season. So they do take this stuff seriously. So I would just to review some recent developments that may or may not be related to each other, but they are certainly related in the sense that they are all occurring right now. Some of you may have followed the detection of the top quark in a recent series of experiments at CERN in Geneva. Well, this essentially ends an entire program of nuclear and particle physics that's been carried on since the 20s. Now the quark model of matter is essentially complete in its more modest formulation. All the predicted particles have been detected. There is good agreement between theory and theoretical formulation. And this represents the culmination of an effort to come to grips with matter that's been underway since the Greeks. And it essentially, in 1994, the general sense is that it's now pretty well nailed down. This is astonishing and ends a whole intellectual effort that, as I say, began with the Greeks, gained momentum with Newton, gained incredible intellectual focus throughout the 20th century, and is now completed. It's the equivalent of the sequencing of the human genome in biology, which is the next subject that I wanted to mention, which is this project, which was slated to be finished around 2020, is now probably going to be finished well before 2000, because once they got into it, they discovered that it's like riding a bicycle. The more you do it, the easier it is to do, and very, very sophisticated computer-driven chemical simulation techniques have been invented, and the human genome is just filling up like a crossword puzzle day by day, week by week, as we speak.
Could you explain what that is? I don't know what that is.
Oh, well, every organism in nature is specified by a unique sequence of chemical labels called nucleotides, and they are stored in the DNA. And this nucleotide message, in the case of human beings, is like up to 20 million units long. And it's basically the script for a human being. Now, whether you get you or me depends on whether the switches are set in up and down positions, but all human beings have the same gene sequence, it's called. And so if you can sequence, if you can determine the human genome, you can predict the occurrence of all kinds of hereditary diseases and, have a kind of utopian approach to medicine where everyone throughout their entire life knows what they are at risk for, and in contemplating any possible pairing for procreation, just down to a gnat's eyelash what the child's genetic predisposition for various diseases and enzyme deficiencies and this sort of thing. Well, so this is happening, and at a startling pace.
Can I ask you something?
Sure.
So if you say that it's predetermined, is that like, do we have anything to say about it? I mean, can you prevent then?
Oh yeah, you can definitely prevent, because you see, if you can locate where on the genome the defective gene is.
How do you spell genome?
Genome.
N-E, okay.
If you can locate where in the genome the problem is for any genetic defect, then you can design a repair gene that can go in there and actually just scissor the bad piece out and put the good piece in. And this is not science fiction. This is being done in the laboratory now, and it's happening. The main point of what I'm talking about tonight is all these crazy, far-out Flash Gordon things are well advanced, and yet, and the other point, highly ignorant of each other. So that the cross-fertilization process that is really going to make all this come into a kind of new paradigmatic order hasn't yet been revealed. Okay, so, other items. And some of these range toward the, oh wow, remember ultimately this is just a laundry list of things on my mind. The events that will occur in the vicinity of Jupiter in the third week of July of this year are extraordinarily interesting from all kinds of points of view. Are you all aware of what I'm talking about?
No.
Okay, in January an object was detected breaking up under the tidal forces of Jovian gravity, and this object was named Schumacher-Levy 9. And it is now in about 25 pieces that are 3 to 5 kilometers in diameter each. And the Newtonian mechanics of this decaying system of orbits dictates that between the 19th and the 26th of July of this year, these objects will smash into the planet Jupiter on the dark side, on the side turned away from the Earth at the moment of impact. But because, well, it's a fascinating event for many reasons. First of all, it's going to churn up an enormous amount of material from deep below the cloud tops of Jupiter, and within 6 hours, the parameter will turn into view of Earth-based telescopes. The other thing is, these planet crushing events, these collisions of large objects in the solar system, have a very interesting and not fully understood role in the formation of our own Earth and the way the history of life has developed on it. For example, and this is the next new thing I wanted to talk about, there has been a sudden coalescence of agreement in planetary geophysics over the past 6 months over a problem which may not have been bothering you, but bothered me, which was, where did the moon come from? And there have been, for hundreds of years, different theories. I mean, clear back to Laplace. One theory, Laplace noticed that galaxies and solar systems, everything condensed down out of dust, and he put, this is in the 1770s, put forth the very plausible theory that the moon simply was an aggregation of material in the same way that the Earth was an aggregation of material and that it formed around the Earth. Well, then there are problems with this, technical problems. It just doesn't check out. So then another theory that had its vogue was that the Earth was spinning very rapidly in its early history, and a blob, actually it just separated off, a hot blob of stuff which went off into space. Suddenly, new techniques for analyzing Apollo rocks and stuff brought back from the moon and all kinds of conferences and so forth, they figured it out. And the answer is extraordinary, and none of the above. The answer is that 4.1 billion years ago, the Earth was struck by an object the size of Mars, and that in this catastrophe, enough ejecta went into orbit around the planet to condense as the moon. It's remarkable that such a catastrophic and dramatic theory could get unanimous acceptance in the field of planetary science, where all this stuff is most haggled over.
What was the planet the size of Mars that hit the Earth? Was it Mars or?
No, it wasn't Mars. It doesn't exist. Its core has now sunk into the core of the Earth. It had an iron core. It is now part of the Earth, and the lightweight pyrocene ejecta formed the moon. And if you're interested in this month's Scientific American has it on the cover. A photo of the event. So, just extraordinary revolution in theory in a very fundamental matter, because, some people claim that the moon was captured and that it was captured as recently as 65 million years ago, and that the complexity of mammalian phylogeny is related to the presence of the moon, and now all that's out. The moon is very old. It emerged in this catastrophe basically at the moment of the solidification of the surface of the Earth. It was a climactic event that came at the end of a series of asteroidal infalls that basically built the planet. So then, other things.
How does that tie into this thing with Jupiter then? Is that just to give us an idea how that happened? Or what?
Yeah, that we've never had an opportunity to observe anything like this. The extinction event which killed the dinosaurs and created the beginning of the Mesozoic era 65 million years ago was not as energetic an event as this thing that's going to happen in July. Yeah. It was very interesting to watch how the scientific press played this thing, because like Schumacher-Levy 9 was discovered on January 9th, and the Bulletin of Astrophysics on the 12th broke the news to everybody who wasn't already following it on email or something. And they called it a once-in-100-million-year event, which, interesting that this once-in-100-million-year event would occur at a moment when human beings have instruments on their way to Jupiter. So then within a month, they had it down to once-in-a-million-year event. And now I think they're saying nobody has any idea. This may be once every 100 years it happens. But it's very interesting. The explosion will be so large, and since it can't be directly seen by Earth-based telescopes, the energy release will be measured by measuring the flash of reflected light off the moons of Jupiter. In other words, they will rise in luminosity and then fall very suddenly as this explosion takes place on the back side. So, that's that. Sort of in line with all of this, and with a kind of an Esalen spin on it, something very interesting that's been going on, if you're a fan of the history of science and ideas, is that in the last 6 months there's been a very interesting effort to look again at David Bohm's work. David Bohm is now dead, and I believe he taught here or he visited here many times. In any case, his ideas are well known here. And he was sort of always our physicist, our meaning the slightly flakier end of things. And for that reason, he was not taken seriously as he should have been in the halls of physics. Well, then I think he died about 18 months ago. Well, now, in Scientific American and in Physical Review letters, there have been long editorials saying that a problem which has haunted quantum physics throughout the 20th century could be solved by admitting that the Copenhagen school, which is Niels Bohr and Heisenberg and all those untouchable and godlike figures, to admit that they were actually wrong about something fundamental, and that David Bohm's quantum physics, which gives the same numerical results as theirs, is in fact a more elegant formulation. And what it is that is at issue here is something that everybody who has concerned themselves with quantum physics for 10 minutes has encountered, which is the famous uncertainty conundrum. Every school child knows by now that you cannot determine the velocity and the absolute position of an electron at the same time. Because as you bring velocity into focus, absolute position smears out. As you bring absolute position into focus, velocity smears out. This is called the uncertainty principle. And probably more muddle-headed prose has been generated around this problem in physics in the last 70 years than in any other. Well, it turns out that if you go with David Bohm, there is no uncertainty. You can know the position and the speed, the velocity, with perfect certainty at the same moment of time. The problem is, and the reason why he was never taken seriously, is that all these quantum formulations carry with them certain metaphysical baggage that is hard for other theorists to accept. And the impossible baggage that Bohm's theory carried was what is called non-locality. Non-locality. This is the peculiar feature of nature which is built into Bohm's formulation of quantum physics, that any two particles ever associated with each other at some time in what we call the past maintain a magical and instantaneous connection with each other, no matter how far apart they are, for the rest of their existence. And that this is not subject to the inverse square law that determines the speed, that slows the speed of light. This is some kind of magical property which is instantaneous. Well, this seemed so outlandish that it was just thought to prove on the face of it that Bohm was wrong. Because they said, well, look at the consequences. If you were to accept this, this insane thing would be built in there. But now, because of what's called Bell's theorem, they are actually doing experiments which demonstrate, in the same way you demonstrate the charge of the electron or the speed of light, they're actually doing experiments which demonstrate that non-locality is real. You associate two electrons, you pass them through a grid of some sort which separates them. You capture one of them, determine its charge, flip it to its opposite charge, and having captured the other one, you notice that when you flip the charge on one, the charge on the other one automatically reverses instantaneously, and that these things behave as though they never left each other's presence. Non-locality. Well, this sets the stage for a staggering realization, because if the universe is non-local in terms of information, then all the raving over the past 30 years about holographic universes and psychedelic plenums and the monadic, fractal, higher dimensional, akashic hoo-ha, all that is suddenly begins to gain vindication. And okay, so that's all happening. Meanwhile, 3 doors down the hall in the branch of things marked information theory, they're realizing that there is a way to analyze physics so that what you get is that that what we call matter is simply information in association with energy. That information associated with energy is matter. So then you go back to this other branch of understanding, and they're saying that information is non-local. And then what that begins to sound like then is that matter also is non-local in some sense. And if you could download that into a technology, you could walk from here to Zenebel Ganubi without ever going through high vacuum. And that would be big news. You understand what I'm saying? Good. Yes, it would be reasonable to ask a question at this point.
So how does the principle of non-locality come in to prove that you can determine position and velocity at the same time?
Oh, it doesn't. It's simply that as a consequence of accepting the parts of his theory which allow you the absolute prediction of velocity and position, you get, as a kind of, you can't not order it side dish, this non-locality thing. And when really a way of talking about non-locality is to say, and then this goes to a whole other branch of knowledge that's also just boiling at fever pitch, is to say, well, then what we're really saying is that the universe is fractal, that it's an enfolded set of values such that you can extract the whole story from any subset. And again, all of this, complexity theory, chaos dynamics, fractal mathematics, what's happening is that the computer is allowing us to go beyond the mathematical objects of Greek philosophy, which were, what did we have? We had the cube, the perfect circle, the dodecahedron, so forth and so on, and then through the genius of Newton and Leibniz and that crowd, the infinite set of ellipses that we could extract from the section cone that allowed us to do calculus, that allowed us to do modern science, but that's sort of where it ended, with Newtonian mechanics and then statistical mechanics to handle the quantum. But now, with chaos dynamics and fractal mathematics and complexity theory, we are actually producing mathematical models of nature that are more like nature than anything we've ever seen before. And it's, in a sense, the culmination of the holy grail of a certain branch of human thinking, that out of numbers and their relationships, which are, after all, objects in the human mind, whatever that is, comes this incredible close correspondence to nature, which is the most remotely removed and ontologically independent thing we know vis-a-vis the human mind. Okay, so that I was a little pan to David Bohm, and then moving through that, And going further, Ilya Prigozhin, who has also been to Esalen and had an influence on many people who taught at Esalen, and me among them, although I was just sort of like sharpening his pencils at that stage, who has already established his track record by winning the Nobel Prize for Physics by destroying the second law of thermodynamics, which was no small accomplishment, believe me, because there was no law of nature to emerge in the 19th century more tenaciously believed in than the second law of thermodynamics. And Prigozhin just showed that, it was a generally true statement of a rather complex situation in which actually sometimes it was bunk. And he secured that mathematically. That was 20 years ago. Now Prigozhin is coming forward with a theory that I modestly suggest sounds somewhat like my notion about time. That time is, first of all, not a construct of the human mind. It is, in fact, a property of the universe, like energy, like matter. It's a thing, is what we're trying to say here. It's not an abstraction, and this is not the first time science has had to make this leap. I mean, the curved field, the electromagnetic field, was at first thought to be some kind of weird mathematical contortion you had to go through to understand electricity, but couldn't possibly actually have anything to do with what it was. And then it was realized, that it was actually a point-for-point description. So Prigozhin is beginning to say that time is a thing, and that therefore it has an arrow, and that complexity is conserved as you approach the present, which is what I've been saying year in and year out here for a while. I didn't call it complexity, I called it novelty, and used Whitehead's vocabulary. But there is, a very exciting convergence of intuitions here that seem, really to hold the possibility of a whole new way of thinking about time and determinism and novelty and the build-up of structure in time.
I understanding that your theory of novelty was that it was not conserved but increasing.
Well, what I mean by conserved is that its general tendency is to never slip back. In other words, once some novelty is achieved, it's tenaciously retained, and it becomes instead the foundation for new novelty. And that's how novelty increases over time, by building on pre-established levels of novelty. So that, for instance, molecular structure, very novel at its inception, becomes ultimately the precondition for biology, a later arriving phase of novelty. And then culture builds on biology and so forth, like that. Yeah.
So when you said that, what was the other term? Not novelty, but Prigozhin.
Complexity
is maintained as we get closer to the present.
Yes, that complexity seems to be clustering near the present.
Meaning this present or any present?
No, this present.
Okay.
In other words, what he's saying, part of his breakthrough, is he's saying the arrow of time is real. It is, the universe is from end to end oriented in one direction. It isn't an artifact of human perception. This is a break with ordinary physics, which insists that all these transforms can be run backward in time as well as forward. He says no, and that's what I've been saying. My conception is that the cosmos is what I call a novelty-conserving engine, and that it through a sort of a one-step, two steps forward, one step back process, marches ever deeper into novelty, and ever faster. That's the other thing that interests me, because I am now I have a very palpable sense that time is accelerating, and that the convergence of some of these things we've been talking about is going to eventually lead to a discussion of what is the nature of time and experience, that in fact history does seem to be ending. This sort of vague and murky intuition of religious ontology is now respectable in physics laboratories. And the presence of human culture on the planet at this incredibly advanced state of acceleration and novelty seems to indicate that, we are making it impossible for ourselves to go anywhere but into another kind of cultural dimension.